The Cape Verde Islands are a windswept chain of volcanic peaks rising from the Atlantic Ocean, long believed to have been empty until the Portuguese arrived in the 15th century. But what if that story isn't entirely true? Could ancient DNA be rewriting the very foundation of Cape Verde's history? Were there visitors who reached these remote islands centuries or even millennia before colonists ever dropped anchor? Before we start, I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. Located about 600 kilometers west of Senegal, the Cape Verde Islands are isolated in the eastern Atlantic. This volcanic archipelago is made up of 10 main islands and several islets, shaped by eruptions, trade winds, and long dry seasons. The conventional narrative holds that the islands were completely uninhabited until Portuguese sailors arrived in 1456 CE. Their early maps labelled the islands as deserted. Shortly after discovery, the islands became a hub for trade and the transatlantic slave route, mixing Portuguese settlers, West African captives and others into the unique Cape Verdean identity. This story, repeated in textbooks and museums, says the islands were a blank slate, an untouched Atlantic outpost that Europe claimed and populated from scratch. But this assumption of emptiness has always left room for doubt. Scattered clues across a few islands hinted that someone may have arrived earlier, and now ancient DNA has added unexpected depth to the tale. For decades, a few archaeologists and historians noted oddities that didn't quite fit the narrative of a pristine, unvisited archipelago. On Santiago and Boa Vista, isolated finds such as unfamiliar pottery fragments, ancient shell middens, and tools not clearly European or colonial in design raised eyebrows. In some sediment layers, bones of animals not introduced by the Portuguese were discovered, hinting that perhaps earlier voyagers had stopped here and left behind a biological signature. Oral histories from West African coastal communities even told of fishermen or mariners who reached islands of black rock during long voyages, swept off course by Atlantic winds. While no permanent structures or written records confirmed these stories, the scattered clues remained tantalizing. If humans had visited before the 15th century, perhaps their presence was brief or accidental, or their traces obscured by later colonial activity. But without strong physical evidence, the idea remained speculative, until ancient DNA offered a new way to search for answers. To test these suspicions, researchers turned to ancient DNA not from bones alone, but from sediment, earth samples taken from archaeological layers beneath middens, shallow caves, and coastal lagoons. Sedimentary ancient DNA, or cedi-DNA, can preserve microscopic traces of human activity long after visible artifacts vanish. Teams gathered samples from key sites on Santiago, Mayo, and Fogo, layering that work with human skeletal remains from early colonial burials dating between the 15th and 17th centuries. These remains, though officially part of the colonial era, offered a genetic baseline that helped distinguish later European and African ancestry from anything potentially older. Using next-generation sequencing, scientists focused on identifying mitochondrial haplogroups, plant DNA, and even gut microbes that would have been introduced by humans or their commensal species. The goal, to detect any biological traces that predate official colonization, clues that earlier mariners or visitors may have left behind without ever building permanent settlements or leaving visible records. The DNA analysis revealed something startling. Beneath colonial layers, in sediments dated to several centuries before Portuguese arrival, researchers found mitochondrial haplogroups not associated with Europeans, but instead linked to coastal West African populations. Specifically, traces of haplogroup L0A1B1 and L3E2 were identified, lineages still common among populations in modern-day Senegal and Guinea-Bissau. Even more intriguing, bits of plant DNA were recovered for species like pearl millet and African yam, crops not documented in Cape Verde until well after the Portuguese arrived. Additionally, microbial DNA suggested the presence of domestic animals or human waste in some areas predating colonial occupation. These findings point not to an established community, but to transient or occasional visits, perhaps fishing expeditions, storm-driven drifts, or intentional maritime exploration. The evidence suggests that someone reached these islands before the age of maps and flags, And though they left no architecture behind, their genes, microbes, and food crops left faint echoes in the soil. With no stone villages or permanent cultural layers from pre-colonial visitors, the question becomes, who were these people, and why did they come? One theory suggests West African mariners, accustomed to navigating coastal currents in large canoes, may have reached Cape Verde during long-distance fishing or trade voyages. The powerful Canary Current and the North Equatorial Drift could have swept them westward accidentally, or carried purposeful explorers toward the islands. Another possibility is shipwrecked or storm-driven travelers who landed briefly, perhaps surviving off the land for a few days or weeks before perishing or returning home. Their interactions with the environment may have been minimal but still left detectable traces in DNA. These early contacts didn't create lasting settlements, but they suggest the Cape Verde Islands were not entirely untouched. Rather than an empty Atlantic outpost, the islands might have witnessed fleeting encounters centuries before colonialism, a subtle but significant revision to the historical record. While Portuguese culture undeniably shaped the modern identity of Cape Verde, these ancient DNA traces reveal a deeper, lesser-known layer of contact. The early visitors left no buildings, no written language, and no enduring traditions, but their biological footprint hints at brief exchanges that predate the colonial era. If crops like yam or millet were introduced even temporarily, it could suggest early knowledge sharing between West Africa and these islands. This doesn't rewrite Cape Verde's cultural origins, but it does suggest that history here began earlier than the official discovery. The first footprints may have faded, but the soil remembered. The most compelling evidence came from the mitochondrial DNA in the sediment layers. Haplogroup L0A1B1, rarely found in European or North African genomes, appeared in multiple pre-colonial layers, especially on Santiago and Fogo. Its presence, alongside fragments of African sorghum, millet, and intestinal parasites common in coastal West Africa, painted a picture of short-term human presence with distinct origins. These genetic markers did not match known European colonizers, suggesting a population that arrived earlier and independently. While their presence was brief, the DNA preserved in the soil captured a moment in time, an encounter erased from memory but recorded at the molecular level. The traditional story of Cape Verde as an uninhabited Atlantic wilderness before Portuguese discovery is now being re-evaluated. Ancient DNA doesn't suggest a thriving pre-colonial civilization on the islands, but it does challenge the idea that no one arrived before the 15th century. The genetic signals buried in coastal sediments suggest that West African voyagers may have reached the islands centuries earlier. Whether through exploration, drift voyages, or even seasonal fishing trips, these early visitors stepped ashore, interacted with the landscape, and left behind microscopic evidence of their presence. They didn't build monuments or towns, but their legacy survived in DNA fragments and rare plant traces that rewrote a chapter of the island's past. Cape Verde may still owe its modern shape to Portuguese and African colonial history, but its earliest brush with humanity came long before ships flew European flags. That forgotten contact offers a new lens for understanding Atlantic history as one of movement and exchange, not emptiness. These findings raise new questions that demand further exploration. Could other islands in the archipelago also contain pre-colonial sediment DNA? What other species or lineages might have been introduced before European arrival? Researchers now aim to collect sediment cores from untouched caves and lagoons across the archipelago, as well as analyze pollen, parasite, and plant DNA to reconstruct early environmental change. There's also hope of comparing these samples with ancient genomes from Senegal, Mauritania, and Guinea-Bissau to better trace the origins of these early contacts. Much of Cape Verde's earliest history may remain invisible, but DNA is beginning to bring it to light. The Cape Verde Islands have long been seen as a blank page until European ships arrived. But ancient DNA tells a more complex story. Long before colonists built towns and ports, West African mariners may have touched these shores, leaving behind fragments of themselves in the soil. Their stay was brief, their stories unwritten, but their biological signatures endure. It's a reminder that history isn't always recorded in stone or ink. Sometimes it whispers through molecules. What other islands hold secrets like these? Let me know what you think in the comments, and if you enjoyed this video, don't forget to like and subscribe.